Welcome to educator.com. This lesson is about solving two-step inequalities. In this lesson, you will learn to solve two-step inequalities. Applications are finding out how many items can be bought on a budget. An inequality is a mathematical sentence that contains the symbol less than, greater than, less than or equal to, greater than or equal to, or not equal to. Properties of inequalities are the addition property of inequality, subtraction property of inequality, multiplication and division properties of inequality. Let's go into solving some two-step inequalities. Negative 2x minus 8 is greater than negative 14. So first, just as in solving a two-step equation, you want to work with the operations in backwards order of your order of operations. So for example, here I want to work first with the subtract 8, and I'm going to add 8 to both sides. So I have negative 2x is greater than negative 6. Be careful with your integers. Next, I'm going to divide by negative 2, the opposite of multiplying by negative 2. And remember that when you multiply or divide by a negative in an inequality, you must reverse the sign. X is less than positive 3. I always like to draw the arrow to remind myself to reverse the sign. Maybe you want to circle the inequality symbol. So x is less than 3. Next, let's try x over 4 minus 7 is greater than 25. So I'm going to work with the subtraction first and do the inverse, add 7 to both sides. So x over 4 is greater than 32. And next, the opposite of dividing by 4 is multiplying by 4. This time I'm multiplying by a positive number, so I'm not going to reverse my inequality sign. Do 32 times 4 over here. That's 8 and 12, 128. And then next, I'm going to solve negative 5y plus 9 is less than or equal to 54. Let's write our answer up here for the previous one. X is greater than 128. I'm going to work with the plus 9 first and do the inverse, which is subtracting 9. Negative 5y is less than or equal to 54 minus 9. So that's going to be 14 minus 9, which is 5, and we borrowed, so 45. And our last step is the inverse of multiplying by negative 5, which is dividing by negative 5. And we're dividing by negatives, so I'm going to draw an arrow here so I remember that I must reverse my inequality sign. That's going to be negative 9. So y is greater than or equal to negative 9. So all of the steps in solving two-step inequalities are very similar to solving two-step equations. The only difference is that when you multiply or divide by a negative value, you must reverse the inequality symbol. Let's try writing our own two-step inequalities to solve. You have $40 to spend at the mall. You want to buy some shoes for $24.99. You want to spend the rest of the money on socks, which cost $2 a pair. At most, how many pairs of socks can you buy? So $40 is the most that we can spend. We can spend exactly 40 or we can spend less than 40, but no more than 40. We know that we're buying shoes for a flat rate of $24.99. And then we're buying some socks at $2 a pair. So I'm going to say 2p. We have our money for the shoes. We have the $2 per pair. And we don't know how many pairs, so that's our variable. And we know the most is $40 that we can spend. So I'm going to subtract the $24.99 from both sides. And 2p is less than or equal to. And in this case, I know that the extra cent for the $24.99 is not going to get me an extra pair of socks, so I'm going to estimate that to $25. This is very close to $25, and that 1 penny is not going to make us a difference in figuring out how many socks. And 3 minus 2 is 1, so 15. 2p is less than or equal to 15. And now we can divide by the $2, so we have $15 left over, and we divide by 2, and p is less than or equal to 7.5. Well, I can't buy half a pair of socks, so instead of buying 7.5 pairs of socks, I need to figure out if I'm buying 7 or 8. If I buy 8 pairs of socks, I won't have enough money. So then I know that even though I'll have a little bit of money left over represented by this 0.5, I have to go to 7 pairs. So I can buy 7 pairs. Let's work backwards and check. If I take the $24.99 and estimate that to $25 and then buy 7 pairs of socks at $2 a pair, that's $14. If I add that up, I get $39, and that's very close to the $40. If I had bought 8 pairs, I would have had to pay $16, and as we can see, that would have been over our allotted budget. So we had an extra dollar left over because we only spent $39 and we were able to buy 7 pairs of socks. Let's try writing another two-step inequality. Beth has $20 to spend on school supplies. She needs to buy a binder and folders. The binder costs $6.99 and each folder costs $2.99. How many folders can she buy? Well, I'm going to estimate this binder to $7 and estimate each folder to $3. Because I know that the pennies left over will not be enough to buy an extra binder or buy an extra folder. So $20 is how much Beth has, and that's the most she can spend. She can spend exactly $20 or she can spend less, but she can't spend any more. She's going to buy the binder for $7 and then some additional folders at $3 a piece. So we'll call that 3F because we don't know how many folders. I'm going to subtract the cost of the binder to find out how much is left over for the folders. And if I do 3F divided by 3, I can isolate the number of folders. And 13 divided by 3 will go in 4 times 12, remainder of 1. And you know what? We don't need to worry about the remainder because she's not going to buy just a portion of a folder. She needs to either buy an entire extra folder or just forget about the remainder. So she's going to buy 4 folders. The most she can buy is 4 folders. And then she'll have a little bit of money left over. So we'll say 4 folders. Now let's check our answer. If she buys the binder for $7 and 4 folders at $3 a piece, she'll be spending $12 for the folder. And that gets us up to $19, which is good. She'll have about $1 left over. Let's try solving a two-step inequality involving distribution. So same as if you were solving an equation. You want to first expand your math expression on the right, and then you can use the two-step. So negative 3x minus 3. Be very careful that you're multiplying by a negative 3. So this negative times a positive becomes a negative in here. And then I'm going to add 3 to both sides. So this is 18 is less than negative 3x, and that's gone to 0. Now I'm going to divide both sides by negative 3. Remember that when you're dividing by a negative, your inequality sign must switch. So I'm going to put an arrow there so I don't forget to switch it. This becomes negative 6 is greater than x. And in algebra, we generally write the variable first. So I'm going to flip it around x. And notice that the closed side is facing x. So I'm going to make sure the closed side is still facing x, negative 6. We have 0.7 minus 2.5g is greater than or equal to 8 1/5. So here we have a mixture of decimals and fractions. I'm going to change this 8 1/5 into a decimal. You keep the whole number 8 and you take the fraction and divide the numerator by the denominator. We've covered this in an earlier lesson of changing fractions into decimals. 5 doesn't go in, so we put a decimal here, and here comes our decimal, and it'll go in perfectly 2 times. So it's 8.2. You take the 8, and then the 1/5 is the 0.2, so 8.2 is greater than, is less than or equal to 0.7 minus 2.5g. Now I'm going to subtract 0.7 from both sides. Remember that you look in front of the number for the symbol. You don't look here. So this negative goes with the 2.5. This 0.7 is a positive, so we're going to subtract 0.7. Cancels. I have negative 2.5g is greater than or equal to 12 minus 7 is 5. 0.7. And now I'm going to divide both sides by negative 2.5. And I'm dividing by negative, so I'm going to draw my arrow to remember to reverse the inequality sign. G is less than or equal to negative, positive divided by negative. And you could think about 25 into 75. How many quarters go into 75? And that's 3. So G is less than or equal to negative 3. So here in this problem, you can see that it's really a culmination of many lessons now. We're changing fractions into decimals. We're thinking about two-step equations and working with integers and decimals and remembering to reverse our inequality sign. You may want to review that example again. A baker has at most 18 cups of flour. The baker makes a batch of bread that uses 12 cups of flour. A batch of muffins uses 2 cups. Write and solve an inequality to find how many batches of muffins the baker can make. You can just disregard this space here. 2 cups. So the baker has at most 16 cups. At most. So he maybe has less than or exactly equal to. He makes a batch of bread that uses 12 cups. So he's already used up 12 cups. And he's got some extra flour, and so he can make batches of muffins. So I'm going to say plus 2m. M will represent the batch of muffins. And we know that each batch takes 2 cups. And we know that these 12 cups have already been used up for the bread. So I'm going to subtract 12 from both sides, leaving me 2m. Let's take out all the flour that we need for the bread so that what we have left over is used for the muffins, leaving 6. Divide by 2, and m is less than or equal to 3. So the baker can make up to 3 batches. He doesn't have to make 3 batches, but the most he can make is 3 batches. Your sister is celebrating her birthday. She is planning on renting a hall for $300. The meal for each person costs $15. The decorations cost $100. Your parents have given her $1,200. How many people can attend the party? So the most she can spend is $1,200. Maybe she'll spend less or maybe she'll spend exactly $1,200, but that's the most. She's already spent $300 for the hall. She's spending $100 for the decorations, and she knows that each meal costs $15 per person. We don't know how many people, so that's P for people, and $15 for each person. That amount is changing. The amount for the hall and the amount for the decorations don't change, but the amount for the meals is going to change. So 300 plus 100 is 400. That's the flat amount that she has to pay just to get the hall and decorate it. So let's take out the 400, and once we take out the 400, everything left over is going to be spent on the meals. So at this point, let's divide by 15, divide by each cost of the meal to find out how many people she can invite. So 800 divided by 15. 15 will go into 80 5 times, giving us 75. And 15 will go into 50 3 times, giving us 45. Okay, well, we have a remainder, but she can't invite a portion of a person. So let's forget about this remainder, and she's going to invite 53 people. And this remainder represents money that will be left over. It's a portion of a person. It's a little messy. Let me rewrite that for you. So the remainder of the 5 is 5 over 15, and that's going to be a portion of a person, which we know doesn't make sense in real life. You can't have the portion of a person, so we're going to ignore that, and it translates into money left over in this inequality. So the most people she can invite is 53 people, but maybe she wants to invite less. It's up to her.